Let's do a few more problems where we're using the idea of finding a coterminal angle to find some trig functions. What if we're asked to find the tangent of 15 pi over 4? So once again, since 2 pi equals 8 pi over 4, you realize that this is not in the unit circle. So to find the coterminal angle, I'm going to subtract 8 pi over 4. And we get 7 pi over 4, which is in the unit circle. So since 15 pi over 4 and 7 pi over 4 are coterminal angles, tangent of 15 pi over 4 equals the tangent of 7 pi over 4. Now, as I'm doing this problem, I realized we haven't really talked about the unit circle. For tangent, cotangent, secant, and cosecant. We've done lots of problems with cosine and sine, and those are pretty simple because I said the beauty or the use of the unit circle is nice because at each of the special angles we can look at the x and the y and determine the cosine and sine. But now we're asked to find the tangent of 7 pi over 4. Well, 7 pi over 4 is down, it's actually over here. Now I can pretty easily get the cosine and the sine, but what about the tangent? So let's take a minute and talk about the tangent and along with it these other trig functions from the unit circle. Now the one thing about the tangent that's special, that's very important, you're going to use a lot. The tangent of an angle is the same thing as the sine of the angle over the cosine of the angle. Very, very important formula, principle, idea in trig. You're going to use this a lot for all kinds of things. So once again, the tangent equals the sine over the cosine. So therefore, if we want to do the obvious, the cotangent, actually the cotangent, you could think of as 1 over the tangent, or if the tangent is this, tangent and cotangents are inverses or reciprocals, so if you flip the tangent, you get the cotangent. So sometimes you have a cotangent, you'll want to use this idea, 1 over the tangent, sometimes cosine over sine. We've already talked about, but just to make it clear, sometimes you're needing to find the secant. If you can figure out the cosine, you put the cosine at the bottom and you have the secant. If you're trying to figure out the cosecant, if you know the sine, you can put it in the bottom and that'll give you the cosecant. So let's go back. We're eventually going to get to this problem, but let's do a few problems in degrees, since degrees can be easier sometimes than radians. So let's just say we were asked to find the tangent of a 60-degree angle. This is a special angle. It's in the unit circle. Unit circle is really great for cosine and sine, so it's 60 degrees. How can I get the tangent? Well, I'm going to use this property right here. The tangent of a 60-degree angle is the sine of a 60-degree angle over the cosine. So now now go back to my unit circle. If I want to get the tangent of 60 degrees, I can determine that by using the sine and the cosine. So the sine is square root of 3 over 2. The cosine is 1/2. Now this is actually a complex fraction. Let me show you. Some of you might already recognize how to reduce this and cancel it, and that's fine. Let me show you the way you probably learned in math, the way to simplify complex fractions a while ago. If you have one fraction over one fraction and you're not sure how to reduce this, here's the easy way to do it. You can take the top fraction and you write it down, and then you can multiply by the reciprocal of the bottom fraction. That's always sort of the shortcut way to simplify a complex fraction. This works as long as you have one fraction over one fraction. So in this case, the 2's would cancel out, and you're left with square root of 3. How about the tangent of 315 degrees? This is actually a special angle that's on the unit circle. It's down here. Since I'm looking for a tangent, I'm going to do sine over cosine. Negative square root of 2 over 2 over square root of 2 over 2. So once again, we can still use the unit circle to figure this out. We just have to use both the sine and the cosine. Now if you see, square root of 2 over 2 over square root of 2, top and bottom are identical. I do have a minus sign. So basically, that's how you find tangents on the unit circle. So now I go back to the original problem, way at the top. We started tangent 15 pi over 4. This angle is not in the unit circle, so I found the coterminal angle 7 pi over 4. So now we're at tangent 7 pi over 4. So now we know how to handle and use the unit circle to find the tangent. So I go to 7 pi over 4, and I need the sine and the cosine. Oh, I actually just did that. 7 pi over 4 is the same thing as 315. But anyways, negative square root of 2 over 2 over square root of 2 over 2. Negative 1. Let's do a few problems in radians. How about cotangent of 5 pi over 6? Now actually there are a couple of ways to do this. You could find the tangent and put it in the bottom, although actually using the unit circle, I think it's probably easiest to just do this. Cotangent's cosine over sine. So if I go to the unit circle to 5 pi over 6, it's over here. Cosine second square root over 2 and 1/2. Complex fraction, if you do what we did a minute ago, you write the top fraction, multiply it by the reciprocal of the bottom fraction, the 2's cancel. Cotangent of 5 pi over 6 should be negative square root of 3. Let's do a couple more interesting ones. How about let's do a cosecant, and let's have to use a coterminal angle. How about the cosecant of negative 4 pi over 3? Now what I'm going to do, I will probably, since cosecant gets paired with the sine, I'm going to go look for the sine of 4 pi over 3. And then either, if it's a fraction, I can flip it to get the cosecant, or put it in the bottom to get the cosecant, whatever. I'll just see how it looks. Now, negative 4 pi over 3 is not on the unit circle. So I need to find the coterminal angle. Since this is a negative angle, remember, we have to start adding 2 pi until we get inside the unit circle. Well, 2 pi with the denominator of 3 would be 6 pi over 3. So to add 2 pi, I really add 6 pi over 3, and that's 2 pi over 3. So the sine of negative 4 pi over 3 is really the sine of 2 pi over 3. So that is a special angle. It's right here. The sine is square root of 3 over 2. So if the sine of negative 4 pi over 3 is square root of 3 over 2, and I went to cosecant, I could just flip the sine to get the cosecant. And that should be your answer. Okay, so I wanted to do these because in the previous video where we learned about coterminal angles and finding trig functions, I think all the examples were sine and cosine, and I realized that we had not done any problems like with tangent or cotangent or the other trig functions from the unit circle. Maybe I'll just do one more. How about the secant of negative 3 pi. Well, for the secant, what I really want to do is go find the cosine of negative 3 pi. Once I know the cosine, I can find the secant. Of course, negative 3 pi is not in the unit circle. So it's the negative angle. I'll add 2 pi until I get it inside the unit circle. So if I add 2 pi, I'm negative pi. Add 2 pi again, I get to pi. So the cosine of negative 3 pi is the same thing as the cosine of pi. Now we know the cosine of pi is negative 1. So now this is a case where I will use the idea that the secant of negative 3 pi is the same thing as 1 over the cosine of negative 3 pi. Because this is just 1. So then the answer would be negative 1. All right. Coterminal angles and the unit circle, very powerful in order to figure out some of these trig functions.